Okay, this is a video to finish the last part of the notes that we didn't complete in the class before. And once you have these notes, then you can go ahead and do the last two problems, 18 and 19 on your homework. On number 12 and 14, they're just like 11 and 13, but we're just going to get some more practice of this. If you've got multiple radicals and they're multiplied together and you've got the same number on the shelf of the radical, your goal then is going to be to merge them into one radical, and then you can go ahead and simplify it. So on number 12, they all have a 5 on the shelf, so we need to take the fifth root, but we're not going to take that fifth root until we combine them into one radical. Well, 4 times 8 is 32, and 32 times 12 is 384. So that's going to give us the fifth root of 384. Well, if we put that into our calculators, it's not going to come out evenly. So we're going to make a factor tree. And I'm going to write it over here where we have a little more space. So 384 divided by 2 is 192. Divided by 2 is 96. And we get 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. And we are looking for groups of 5. 1, 2, 3, 4, 5. And I knew it was groups of 5 because that was the number that was on my shelf. Okay, so each group represents one number outside of the radical. I've got the fifth root, and then anything not circled goes back underneath and gets multiplied. So this is 2 fifth root. 2 times 2 is 4 times 3 would be 12, and that's my final answer. Okay, let's do this again on number 14. This time we've got numbers and variables, but that's okay. What is important is that we have the same number on the shelf, which is the invisible 2. So that means we can combine them into one and then take the square root. Okay, so for the numbers, 3 times 3 is 9. For the variables, x to the 7th times x to the 3rd. When I multiply variables with the same base, I add the exponent. So 7 plus 3 is 10. So I get x to the 10th. But the y's, 4 and 5, would give me 9. Now, to get my answer, I'm going to take the square root of everything. Square root of 9 is 3. Square roots, remember, there's an invisible 2. So I'm looking for to see how many groups of 2 are in 10. And there's 5 groups, so I get x to the 5th. How many groups of 2 are in 9? Well, there's 4 of them. 4 times 2 is 8, so that represents 8 of the y's. So that means there's going to be 1 left over, and that 1 left over, or the remainder, will go under the radical. Okay, on this next group, they want us to multiply by the conjugate. So if the original binomial is 4 plus the square root of 3, the conjugate is going to be 4 minus the square root of 3. So now we're going to multiply or distribute, FOIL, whatever you want to call it. But this is good review because we've done these before. 4 times 4 is 16. 4 times negative square root 3 would be negative 4 square root 3. 4 times radical 3 is 4 square root 3. And then at the end, a positive times a negative is a negative. And I have the square root of 3 times square root of 3, which is square root of 9. And the square root of 9 is 3. If you notice, the terms in the middle cancel out, so I just get 16 minus 3, which is 13. Okay, let's try this again on number 2. On number 2, the conjugate of 3 minus the square root of 2 is going to be 3 plus the square root of 2. So over here, now I'm going to multiply. Oops, not too far with my arrow. 3 times 3 is 9. 3 times radical 2 is going to be 3 square root 2. This is going to give me negative 3 square root 2. And square root, negative times positive is going to be a negative. That we know. Square root 2 times square root 2 is the square root of 4, which is 2. But again, the numbers in the middle cancel. So I get 9 minus 2, which is 7. Now, I can give you a lot more examples of this time. But every time we multiply something by the conjugate, these middle terms are going to cancel out. So you can continue to do it this way and you would not be wrong at all. Or you can work smarter, not harder, and just do it this way. So I have negative 2 plus the square root of 5. And then negative 2, the conjugate would be negative 2 minus the square root of 5. Since I know the middle terms will cancel out, I'm just going to multiply the first and the last. So negative 2 times negative 2 is positive 4. and then I have to multiply the radicals. Well, positive times a negative is a negative. Square root 5 times square root 5 is the square root of 25, which is just 5. So I get 4 minus 5, which is negative 1. All right. On the next ones, we need to write this in reduced radical form. And the way that we do this is by multiplying the top and bottom by the conjugate. So the conjugate of 3 plus square root 2 would be 3 minus square root 2. Now on the top, they're not conjugates. So we're just going to have to distribute. That gives me 9 minus 3 square root 2. But on the bottom, they're conjugates, so I can do the shortcut. 3 times 3 is 9. Positive times a negative is a negative. Square root 2 times square root 2 is just 2. Now these 9s, even though it's tempting, they do not cancel out. I cannot simplify the top, but I can simplify the bottom. Now for a second, you're going to ignore the radical. If there is a number that goes into 9, 3, and 7, you can reduce it. But there isn't a number that goes into 9, 3, and 7, and so we're done. Okay, number 2, to write in reduced radical form, we need to multiply top and bottom by the conjugate. So the conjugate of 4 minus square root 3 would be 4 plus square root 3. On the top, we're going to distribute the 1, so I get 4 plus the square root of 3. On the bottom, I'm going to use my shortcut. 4 times 4 is 16. A negative times a positive is a negative. Square root 3 times square root 3 is just 3. You cannot reduce the 4 and the 16 because it's attached by plus and minus. So we need to simplify the bottom first, which is 13. Ignoring that 3, is there a number that goes into 4, the invisible 1, and 13? Other than 1, no, so it doesn't reduce any. Number 3. Number 3, we have to multiply by the conjugate, which is going to be 5 plus the square root of 7. On the top, we're going to distribute and get negative 10 minus 2 square root 7. On the bottom, we're going to get 25. A negative times a positive is a negative. Square root 7 times square root 7 is 7. So this gives me negative 10 minus 2 square root 7 over 27 minus 7 is 18. So we're going to ignore the radical for a second. Is there a number that goes into all three, 10, 2, and 18? And the answer is yes. It's divisible by 2. So this is going to be a 5. This is going to be a 1. And this is going to be a 9. So when I write my final answer, I have negative 5 minus the square root of 7 over 9. All right, last one, I'm going to multiply by the conjugate, which is going to be 2 plus the square root of 5. So on the top, I'm going to distribute, and I get negative 6 plus negative 3 square root 5. On the bottom, use my shortcut because it's the conjugate, and I get 4, negative times positive is a negative, minus 5. So on the top, I have negative 6 minus 3 square root 5, and on the bottom, I have negative 1. Now, if you left your answer like that, I would not count it wrong. That said, if you were looked up in a textbook, they would have multiplied everything by a negative 1, making all the signs positive, or changing all the signs, I guess would be a better way to say it. And because there's a positive 1 on the bottom, I don't need to write it. So the best way to write it is this, but I would not count it wrong if you did it the other way. Okay, now that you've finished the notes, now you can finish the last 2 problems on your homework.